like you have to use all your attempts right now. If you wanted to wait, you could. All right. Moving into today's material, I'm going to start off by reviewing some of the active questions. I'm not going to give the full answer, but I'm going to help you with the setup. Um, Today we're going to be doing the last part of chapter 2, which is really just looking at density and looking how to deal with cubic units in a calculation or in a conversion, because there are a couple of those where you have to convert cubic units, and I'll talk about what we need to do there. We are going to be looking at volume again and all of that, and we talked about yesterday volume being a derived unit where you have to solve things to get there. So if you have access to your active, you can go ahead and pull up question 21. So these type of questions, they're kind of drop and drag, and everything you need is there. It just may not necessarily be set up the way that you think it should be, or the way that I kind of went through. So one of the things that I said, ultimately you're going to have to memorize these metric prefixes. All right. So when we look at this, I'm going to kind of show you an easy way, or the method I use for memorizing them. So if you just look at the kilo, hecta, deca, base, deci, centi, milli, these we should kind of know. If you just memorize that base is 10 to the 0 or 1, for these, all you're going to do, so this way, I'm going up by 1 factor of 10. And then this way, I'm going down by 1 factor of 10. All right. And so on this end, we end up having mega and giga. And then on this end, we end up having micro and nano. So kilo to milli is easy because it's just a power of 1 exponent change. What we have to remember here is when we jump from kilo to mega, it goes up by 3. And then when we go from mega to giga, it goes up by 3 again. And then the same thing here, down to micro is 10 to the negative 6, and nano is 10 to the negative 9. All right, so that's just an easy way to remember the exponents and all of that. So where all I do is I memorize base is 1 or 10 to the 0, and then I can expand from there. And then I just remember where my jumps are. All right, so for question 21, we're trying to go from milligrams to grams. So I need to establish a conversion factor. So grams is my larger unit, so I can say 1 gram is equal to a certain number of milligrams. So when I look here, gram is 0, milli is negative 3, so 0 minus negative 3 is 10 to the third. So I'm just going to hold that for right now. So my first starting point is I'm bringing my given down, 95.0 milligrams. So the first thing I need to see, what unit am I trying to get rid of? Milligrams. So I want to divide by milligrams, so I want to cancel my milligrams. All right, and I'm going 2 grams, and I remember I set that to 1. Now, I'm looking, I said it's 10 to the third. I'm looking down here and looking into my answer choices. I don't see 10 to the third on there, but what do I see that's equivalent to 10 to the third? 1,000. So I'm going to slide that 1,000 right there. And then if you set it up correctly, the computer should automatically X out the milligrams, showing that you're left with grams. So now all you have to do is take 95 divided by 1,000, and it brings it in there. All right. So that's the setup on that. And then you pick your choices down here that represents the answer. Notice that they do put some of them in scientific notation. They put some of them in just standard form. You have to see which one fits your choice the best. All right. Question number 23. I'm skipping 22. Question number 23 is a similar type question, except for notice question 23 gives us more than one given. One of the givens that it puts up there for us is a conversion factor. Which one of the numbers in our prompt establishes a conversion factor? So if you notice, it said we have, anytime you see a unit that says something per something, that is a compound unit or a conversion factor. So this 23 minutes per pound is saying it takes 23 minutes to cook 1 pound. So for every 23 minutes that passes, we can cook 1 pound of meat in 23 minutes. So my given, where I'm starting, is right here at 5.17 pounds. So I'm going to drop my 5.17 in. I'm going to drop my pounds in. So now the question is asking me how many hours. So I'm trying to get to hours in this. I need to figure out a way to get from pounds to hours. And then I have this conversion factor that allows me to go from pounds to minutes. And so I have 23 minutes for every 1 pound. That allows us to get rid of pounds. Now we can go from minutes to hours. So for every 1 hour, there's 60 minutes. Now, putting this in the calculator, most of the time I just put everything that I see in there. So I'll do 5.17, open parentheses, 23 over 1, close parentheses, open parentheses, 1 over 60, close parentheses. I just do it all as one thing. You can multiply everything across the top, divide it by everything across the bottom. Or you could do like 5.17 times 23. And then that answer divided by 60, that's still going to get you to the same place. There's multiple ways for data entry on that. But again, you're looking to see that you're getting rid of the units and ending up with the unit that it's looking for. All right. All right. And then the last one that I want to go over right now is number 24. And this is going to be a similar way. And I looked at this one because I've taught you to go directly from one unit to the other, but this one doesn't allow you to do that. It wants you to go to base unit first. So again, putting up and this time all I need is my standard part on here. So I'm 10 to the 0, 10 to the negative 1. All right. So normally I would set up my conversion factor from kiloliters directly to deciliters. All right, and kiloliters is the larger one. And then I would do 3 minus -1, which is 10 to the fourth. 10 to the fourth is what, 10,000? So I look down here, I don't have an equivalent to 10,000 anywhere on there. So what I have to do is find out what equivalents I do have. I do have 1,000, so that would represent 1 kiloliter to 1 liter, and that would be 10 to the third, which is 1,000. And then I also have a 10, so I can go 1 liter equals 10 deciliters, or 10 to the first deciliters. All right, which is that. So setting this up, I have to actually do this problem in 2 steps the way that my choices gave me. All right, so starting here, I'm going to start with my given, 0.473 kiloliters. I'm trying to get rid of kiloliters. Going to liters, trying to get rid of liters, and I'm going to deciliters. So that gets me to where I want to go. Now I just have to plug in my conversion factors. So for every 1 kiloliter, I have 1,000 liters. For every 1 liter, I have 10 deciliters. Now, before I move on, this is going to be my little soapbox about active. I know this is an online homework and all of that, and it's very easy just to do it all online. I recommend, especially as we're moving forward in there, have a notebook, and maybe even just one of those small, cheap notebooks that is totally dedicated to just doing your active work. And then you do, like, if you're on number 12, right, chapter 2, number 12, and show your work in there. And then that way, if you ever do have a question in class and I'm giving you time in class to work, and you say, I don't know how, can't figure out what I'm doing wrong, I can't see everything that you do, all your attempts. So it will help me to see what you've written out, and then I can quickly see, okay, this is where you're making the mistake. You have this conversion factor inverted or something like that. That just helps me help you. If you just pull up a problem and say, I don't get it, it takes me a little while to see where the part that you're not getting is. So if you have somewhere that you're writing down your work, that is ideal, especially when it comes to practicing for the test. The biggest part and the biggest place that I've seen students make mistake is they will take the online test for Southeastern, and they turn in the packet. Every test that we take, you'll get a packet like this that I give you areas to show the work. And the students that make the lowest scores have the least amount of stuff shown. All right. If you're in the practice of showing your work, you'll actually start seeing your mistakes as you're showing it, as you do enough of it. And that's going to be the biggest thing. All right. So moving forward today, remember that when we're looking at conversion factors, we are establishing an equivalency between 2 known quantities. So, for example, we know, and in your periodic table reference packet, this number's in there. All right, this is an established conversion factor. 1 inch equals 2.54 centimeters. All right. All right. This is an exact number. So in regard to significant figures for your answer, will this ever affect the number of sig figs in our answer? No. Exact numbers don't affect sig figs in your answer. So if you remember from the little science geek thing that I had y'all do yesterday, there was the one where we averaged up all of the numbers, and you got something like 400.005 or something dot dot dot. You got some number that looked like this, and then you divide it by 4. All right, and then the answer that they were looking for on the Science Geek was a number that had 3 decimal places. The reason why that 4 didn't affect the sig figs is because we were considering that 4 as an exact number. We had 4 different samples on there. All of them were measured to the 10,000th place. All right, or tenths, hundredths, thousandths place. Sorry, all of them were measured to the thousandths place. So that 4 dividing it by 4 didn't affect the overall significance of those 0.003. So in this one, the 1 inch to 2.54 centimeters is a sig fig. Now, something about this one, remember that we can also look at it in this direction. And depending on what we're trying to cancel, I can establish it whenever I set it up in my thing. I can put centimeters down here, inches up here, or I could set it up when we're using that as a conversion factor. It can flip either way depending on the unit we're trying to get rid of. So if I'm trying to get rid of inches, I put inches on the bottom. If I'm trying to get rid of centimeters, I put it on the bottom. All right. So I have this problem here that I have 44.7 centimeters, and I want to know what that is in inches. So if I'm using my conversion factor that we just established, what unit's going to go on the bottom and what unit's going to go on the top? Centimeters will be on the bottom because that's what we want to get rid of, right? And we know that for every 2.54 centimeters is 1 inch. Now, approaching this problem mathematically, essentially, what am I doing here? Mathematically, I'm just saying 44.7 divided by 2.54. Because if we do the whole thing, 44.7 times 1 is 44.7. And then I'm dividing by 2.54. All right. So again, since I'm dividing by centimeters, centimeters goes away. And then I'm left with the only unit left is inches. So I get inches. All right. All right. So we end up with 17.6 inches when we get that. All right. Now go ahead. Go ahead and try this one. I want you to convert 194 centimeters into feet. So we know a conversion factor from centimeters to inches. You should know a conversion factor inches to feet. If you don't, well, I actually have it on there. 12 inches is 1 foot. So looking at this one real quick, the conversion factor that we already knew was 1 inch is 2.54 centimeters. Centimeters is on the bottom so that it cancels. And then I need to cancel out inches. So I know for every 1 foot, there's 12 inches. That cancels out inches. And then going through, this is the number that you should have gotten on the calculator. What's the correct answer into the correct number of sig figs? All right, so we started with 3 sig figs here. We can get there. Now, going through here, essentially the problem that we're working is 194 over 12, or 194 divided by 2.54 divided by 12 is the other way to do that. So if you didn't get the number, make sure you're entering it in. Be careful not to do 194 divided by 2.54 times 12, because the calculator is going to read that as you're multiplying your answer by 12. Tell the device what you want it to do. All right. Now, so whenever you have units that are cubic units, so like we dealt with yesterday, we talked about centimeters cubed and all of that. So we've established that 2.54 centimeters equals 1 inch. But if we're dealing with cubic things, where we like doing volume, something like that, or even if we're doing area where it's a squared unit, when we look at the conversion factor, if we're looking at it in terms of volume, we actually have to cube the conversion factor as well. So 2.54 centimeters equals 1 inch actually becomes 2.54 cubed centimeters cubed equals 1 cubed inches cubed. Or when we actually do the math, I don't expect you to memorize this number. I just want you to know to cube it. All right. But 16.387 is 2.54 cubed. So we have centimeters cubed equals inches cubed. 1 cubed is 1, obviously. All right. So if I was trying to take, if I bought if I had something that I needed to know it in cubic inches, two different companies. One has a site in Japan, one has a site in U.S., and we're doing calculations in cubic inches. They're doing it in centimeters cubed. So I would take that, and to do that conversion factor is 1,255 cubic centimeters. I want to get rid of cubic centimeters. So essentially, taking this number, which remember is 2.54 cubed, and then going through and we get that. And again, looking at sig figs, there's 4 sig figs in this number, so we have to have 4 sig figs in our answers. The conversion factors still are considered to be exact numbers. All right. Questions on that? There are a couple of problems in active that you have to do this. Other than today, other than this chapter, you probably won't use that again in the class, but it's a good little thing to know. All right. And then the last thing is density. We're going to have several density problems in this class. Density, the formula for density is mass over volume. So all I really need you to have off of this slide is this or this. Now, I am expecting that you are at a level of math that if I'm solving for volume, you can manipulate the equation to know that volume is mass over density. I'm expecting you to know that if you're solving for mass, it's density times volume. All right. I'm expecting you to be able to make that manipulation. I would only memorize one formula. I'm not going to try to memorize three. A way that we used to teach this in middle school is we did something called the formula triangle. And so you cover up whichever one you're solving for. Volume is m over d. Density is m over v. Mass is d times v because they're on the same plane. That's one way of doing it. I just prefer manipulating the equation. All right. So, like I said, the problems that you're going to get in active are not going to necessarily be directly spelled out. The problems that you see on the test are not always going to be directly spelled out. So you might get one where we have to use density as a conversion factor. So that's where that dimensional analysis comes in. So, so this would be an example of a prompt that we have. For a liquid substance with a density of 1.32 grams per centimeter cubed, what volume should be measured to deliver the mass of 68.4 grams? Now, notice that it says a liquid, and then it gives us our density in centimeters cubed. So for me, if I'm measuring a liquid volume, centimeters cubed is not going to be a good volume. I'm going to use milliliters in the end. So not only am I trying to go from grams to a volume measurement, I'm also going to go from one type of volume measurement to another. All right, so starting this off, I need to go from grams ultimately to milliliters. So that's kind of my flow chart for this. So the conversion factors I'm going to use, I'm actually going to use the density as a conversion factor. Notice that the 1.32 is tied to the grams, and I can flip that either way. All right. So it's 1.32 grams for every 1 centimeter cubed. And then I also have that 1 milliliter and 1 centimeter cubed are equivalent units. So starting it off, I start off with my given, 68.4 grams. My first step is to get from grams to centimeters cubed. My second step is to get from centimeters cubed to milliliters. Now, in my head, since this is 1-to-1, I don't have to plug this into the calculator. I'm showing it because I want to make sure that I'm showing my unit conversion. But I'm not going to calculate that because anything times 1 is 1. Or anything times 1 is that number. So 6.84 divided by 1.32 gives us our answer. And then because grams canceled and because centimeters cubed canceled, our answer ends up being in milliliters. All right. So does everybody get what I did there and why? Now, in the calculator, the only reason why I showed all of this is just to show where my units are canceling and to show that I'm ending up in milliliters. In the calculator, all I'm going to do is 68.4 divided by 1.32. And then for my answer, I'm going to maintain 3 sig figs. All right. So sometimes the problem is not going to give you all the information you need. We're going to run out of time, so I want you to go ahead and take a picture of this one. Huh? So I want you to go ahead, take a picture of this, and then solve it on your own, and then that'll be where we start on Monday. Right now the active is set to close on Sunday, but I'm going to extend it because there's still a little bit I want to cover for chapter 2. All right. Not having school on Tuesday kind of messed me up, and half day today messed me up. So make sure you get that. You should be able to work all of the problems in active. There might be 1 or 2 that we haven't covered, and we can address those on Monday as well in class and kind of finish it out. And if it works out right, we'll probably start rolling into chapter 3 on Monday, or we might do we'll probably do like a kind of little, not a summative grade, but like a closing grade for chapters 1 and 2, like a quiz is or something that covers. Huh? No, you said your friend said this class was easy. Your friends.